Assalamualaikum. Today we will present about carbon tetrachloride. Tetrahedral shape, one carbon atom at the center bound to four chlorine atom. Covalence bond between carbon and chlorine. Non-polar molecular duo is symmetrical structure. Molecular formula CCl4. Used for particle application. For the example, industry, agriculture, last name, medical and firefighting. Nomenclature. IUPAC name, carbon tetrachloride. Common name, tetrachloromethane.
This bubble map shows the physical properties of a substance. It is a colorless liquid with a refractive index of 1.460. It has a sweet chloroform-like smell, a boiling point of 76.7 degrees Celsius, and a melting point of negative 22.8 degrees Celsius. Its density is 55% lower than water, and it is insoluble in water but soluble in organic solvents such as ethanol, ether, and chloroform. This slide presents the chemical properties of a substance. It is non-flammable, unlike many other organic solvents. It remains stable under normal conditions but decomposes at high temperatures. When heated, it produces toxic gases such as phosgene, which is COCl2, and hydrogen chloride, HCl. Additionally, it reacts with strong metals like sodium and aluminum, leading to hazardous reactions.
So, is carbon tetrachloride are synthesis methods or natural source of the molecules? Carbon tetrachloride can be obtained from both synthetic methods and natural source, but it is primarily produced through industrial synthesis. Okay, synthetic methods for industrial production. The chlorination of methane and chloroform. As you guys look at the slide, there is two equations. This process occurs under high temperatures for 400 to 500 Celsius with UV light or catalyzed like FeCl3 or AlCl3. As for the next slide, the chlorination of carbon disulfide CS2. This is some example for equation of the carbon disulfide CS2. It was less common but historically used. As for the next one, we go to natural source. Although mostly man-made, but carbon tetrachloride has some minor natural source, such as volcanic emissions, and marine algae, the producing trace amounts. As you guys look at the picture, there is seaweed. And for the third one is atmospheric reactions. It was involving other chlorinate compounds. And for the next slide, we go to practical application that usually use. The carbon tetrachloride has historically been used in various industrial and laboratory applications. However, due to its toxicity and environmental concerns, its use has been significantly restricted. Here are some practical applications where it has been used. For the first one, industrial solvent. It was previously used as a solvent for oils, fats, resins, and rubber. It was usually used in metal degreasing and cleaning applications. As for the second one, refrigerant, and fire extinguishers. It was historically used. Usually, it was used as a refrigerant precursor R10 before safer alternatives were developed. Once used in fire extinguishers, especially for electrical fires, but it was discontinued due to its toxicity concerns. As for the third one, production of chemicals. It was still used in manufacture of chlorofluorocarbons, CFCs, although CFCs are being phased out due to ozone depletion concerns. They are utilized in the synthesis of other chemicals like tetrachloroethylene (PCE) and trichloroethylene (TCE). As for the fourth one, laboratory applications. It was used as a solvent in NMR spectroscopy due to its lack of hydrogen atoms. It was occasionally used for pesticide and herbicide formulation in research settings. As for the fifth one, military and aerospace. It was historically used as a propellant in some rocket and missile application. As for the sixth one, medical and pharmaceutical. It was previously used as a dry cleaning solvent and in pharmaceutical formulations, but now it was largely banned. For the seventh, cleaning agent. It was a popular cleaning agent for textiles and electronics, but its toxicity led to safer alternative. For this one, it was because of its carcinogenic and ozone depleting properties. Carbon tetrachloride is now heavily regulated under environmental protection laws, and its usage is largely replaced with safer chemicals. As for the conclusions, carbon tetrachloride (CCl4) was once used widely in industries, agriculture, and firefighting. However, due to its high toxicity and environmental impact, its use has been largely restricted, contributes to ozone depletion, leading to a global phase-out under the Montreal Protocol. And it was safer alternative like tetrachloroethylene and hydrofluorocarbons (HFCs) are now used in place of CCl4. That's all from us. Thank you.